Hello, MBA 510 students. This is actually the first video I make for MBA 510, and I decided not to make one on Module 1 because it's basically a reading chapter and it's a lot of generalities and all that stuff. But I'm going to make a video on Module 2, and I'm going to concentrate on estimating total cost lines when you have mixed costs. Because a lot of the first few pages you can it's just basic reading and stuff. But this will, I want to get into the technical aspects of how to estimate total cost lines for projects which have fixed costs and also variable costs, because this is probably the most important type of cost behavior. Mixed costs. Mixed costs are, I'll get into it right now. Mixed costs are types of projects or activities or production processes which have both fixed components and variable components. Okay, so let's go ahead and get started, and I'm going to base this on Excel, okay, and this is the worksheet that we'll be using, okay, and make sure it's the correct worksheet here. It is, okay, and so we're talking about cost behavior here. And what I'm going to do is, first of all, let's just, this should be from your chapter, but basically there's three types of costs. There's all sorts of costs, but from a cost behavior standpoint, meaning how does cost relate to the how many units you produce, there's basically three types of costs. Fixed costs. These are costs which do not vary with the level of production, okay? And you've seen this if you read the book. They're pretty easy. Examples include rent on a factory and insurance on a factory. And if you just think about it, let's say you pay $10,000 a month in rent on a factory. It's fixed by contract. It doesn't matter whether you produce 0 units or 550 units. The rent stays the same. Same goes for insurance. You pay the insurance policy. It doesn't matter if you produce 0 units or 550 units. It stays the same. So these are mostly costs that are fixed by contract. Okay. The next type of costs are what we call variable costs. And variable costs are usually, but not always, this is kind of important, they usually, but not always, they're costs that usually, but not always go in directly into the cost of a product. Okay, as we go on through the course, you'll see that the most obvious ones are direct materials. These are the materials that go directly into a product, and direct labor. These would be in your traditional assembly line factory, people that actually work on the product. Okay, so we have those two types of costs, direct materials, direct labor, and there's other types of variable costs, but I think for our purposes now, we're going to see them as things that go directly into a product. So if you make one product, you're going to use up 1 unit of direct materials and so many hours of direct labor. Make 2, you'll use more, and you make 3, if you make 3 or 4 or 5, the total variable cost goes up the more product you make, which contrasts with fixed costs, which don't vary the product at all. Finally, mixed costs, and this is the usual case. Actually, most production processes, that's the best way, actually are represented by fixed costs. Okay, and most products have both a fixed cost and variable cost component. And we're going to use a line. These are represented by the following linear formula, which can be used to predict future costs. Okay, so what we're going to be doing in all of these these videos that I put together, there's going to be 2 of them, by the way, regarding cost behavior is we're going to come up with an equation that looks like this. Total costs is equal to total fixed costs plus variable costs times the number of units produced. I'm going to make this a little more, I'm going to specify this more. Okay, I'm going to put a little asterisk means times. I didn't even get it in there. Okay, so this little asterisk here means times it's a product. Okay, so your total fixed cost, your total cost is equal to your total fixed cost plus VC, which is variable cost per unit times the number of units produced. So units is the number of units produced. And I'll put that in quotation marks here. Get this running. Okay, so here's our equation. Total cost is equal to your total fixed cost times the number of units that are produced. And that makes sense because if you take the latter part of the equation, if you take that part right there that I just put in bold, take that part, that really gives you the variable costs per unit times the number of units produced, really gives you your total variable costs. If the variable cost times the number of units produced is 0, your total costs are going to be equal to your total fixed costs. Your total fixed costs are at the bottom. You pay that whether you produce 0 units or not. But your variable costs go up as you produce more units. Okay, and we'll be doing an example of this. So the objective of this these two videos, I'm going to start with the high-low method. The objective of these is going to be to estimate this equation. And why do you want to estimate this equation? You want to estimate the equation because you want to be able to estimate forecast going out into the future how much your total costs are at certain levels of production. So that's going to be very important, and we'll get into that. Okay, so anyway, let's do this. There are 3 ways to estimate this equation. The first one, the book loves this one, the high-low method, and that's the one I'm going to finish this video with. We'll start with the high-low method, and the next video is going to finish this worksheet using the scatter graph and regression. Okay, but the book loves this method, and the high-low method is a method which estimates this equation using the high point and low point in a data package or a set of data set. Okay, and then there's 2 other methods which are kind of related. One is you make a scatter graph. You just put the unit data and the cost data on a scatter graph and kind of look for points that are outliers, take those out, and then basically use the high-low method again. And the most scientific one, quote unquote, is linear regression. Okay, and we'll actually be using more linear regression in this class as time goes on. We're just going to do the basis of it today. And as we go on into chapter 3 especially, I'm going to give you problems using linear regression. I want you to know how to use it now using Excel functions. Okay, so what I'm going to do in this video, so I sort of introduced the concepts here. And what I'm going to do in this video is I'm just going to do the high-low method in this video. And then in the next video, I'm going to finish by doing the scatter graph method and linear regression. Okay, okay, so let's go over here to the high-low method, okay? And what we're going to do is we're going to have let's see what we got here. I'm going to erase a lot of this. Let's see what we got here. Go ahead and erase this. I left it in there, and I want you to see how this is done. Okay, so under the high-low method, you're going to use the high point. Here's a data set, first of all. Okay, and the data set pertains to exercise 2-9 in your book. So I'm using 2-9 from your book. In case it's part of the homework, that's fine with me. Okay, and this data set pertains to Pearl Vision. And it pertains to a company called Pearl Vision. I think there is a company called Pearl Vision. Okay, and notice what the data set gives you. It gives you sales orders and total processing costs. I would say total sales processing costs would be a better way to put it. I took it right out of the book, but say total sales processing costs. And all this says is that you have 7 months. These are historical months. Okay? And through these months, you've recorded these level of sales in units. 3,000, these are all units. 3,000 units, I guess they're glasses. Eyeglasses, 3,000, 1,500, 4,400, 2,800, 2,300, 1,200, 2,000. So, okay, and with those sales, you've noticed your accounting department has recorded these differing levels of cost here. Now notice that, and it makes sense that there is a point which is higher than all, both in units and in terms of dollars. So this is your high point. We'll call this the high point. And notice that it's the highest highest cost and unit level. Okay? And let's see if there's a low point. Okay? And so the high point was $120,000 and $120,700 is your high point, and your low point is and that's for 4,400 units. And your low point is this one right here. Here is your low point. And I don't know why they always write it low just with 2 letters, but they love to do that. Okay, so let's go. There's your high point and your low point. Okay, so what we're going to do in the high-low method, just like the method says, is we're going to calculate a line based on, I guess, these data, but you're only going to base it on the high and low points. And the problem with high-low method is, I don't think anybody uses it with technology today, but the problem here is that you have 7 data points, but you're only going to consider in estimating your line the high point and the low point. So obviously, if the high point and low point are outliers, then your line may be a little bit off because you're using 2 points to estimate a data set of 7 months. Okay, so under the high-low method, the high and low activity periods are used to build a line. That's what I'm saying. So first, calculate, I'm going to correct my handwriting there, the variable cost per unit using the high and low points for both the using both the high and low points. And I can just stop that right there. So you calculate the variable cost per unit, which is VC on our equation, using the high and low points. And we already know what the high points and low points are. High point is this right here, and the low point is this right here. Okay, and the equation that we're going to use to do that is we're going to say, we're just going to have here, let's put this here, VC. Remember that VC is your, in the variables that I gave you, is VC is your variable cost per unit. Okay, and I'll go ahead and write out the equation first. Okay, you're going to take the high cost, and I'm going to go ahead and stretch it out because I'm going to try to put as much descriptive detail in here. Like you're going to take the high cost minus the low cost. I'll put that in parentheses. And you're going to put that over the number of high units sold, let's put units, minus the number of low units. Okay, and I'm going to go ahead, and this is just in text, so I'm just going to go ahead and put the numbers and then calculate the number onto the right. Okay, so the high cost minus the low cost, and I'll just do this. The high cost minus the low cost is, the high cost we all know is you can see it right there, is 120,000, is $120,700 minus the low cost, which is $43,100. Okay, and the high units minus the low units, you already see the high units are 4,400 units. Okay, and I'll go ahead and put that in parentheses. And the low units are 1,200 units. Okay, so that's my ratio that I'm going to use right there. Okay, so I'll just go ahead and figure out what ratio I get here, what I get here. So I'll do it here. 120,000 on top minus 43,100 on the bottom. And that's all divided by, and this is going to make parentheses, 4,400 high units minus 1,200 low units. And that's going to give me a cost per unit, a variable cost per unit of $24.25. And so this is your variable cost, and I'm using VC, just variable cost per unit. I'm going to say per unit. Okay, so there's your variable cost per unit right there. Okay, and now we've got to figure out our total fixed costs. So now we've got to figure out, the next thing to do is to figure out your total fixed costs. Then we can put the line together and see what type of things we get here. Okay, so your total fixed costs in the equation are going to be, you can figure them out using either the high point or the low point. You'll get the same answer. So let's do it using the high point, and then we'll calculate them using the low point, just to emphasize that no matter which point you use, you're going to get the same amount of fixed costs. Okay, so for the high point, all you're going to do is you're going to take your total costs. It makes sense. If you take your total costs, this is true for anyone, take your total costs and you take out your variable cost per unit times X, that should give you your total fixed cost. Because remember what the line looks like. The line looks like this. So if you rearrange this algebraically, if you take your total fixed cost minus, or your total cost less your variable cost, that should give you your total fixed cost. I'll let you figure that out algebraically, but I'm basing it on that line right there. Okay, so if I take my total costs, which are high, and I'll just go ahead and write this out, what I'm doing here. So this is all text. So I'm going to take my total cost of 120,000 minus my variable cost per unit, and I got to fix something here, but minus variable cost per unit, which is $24.25. What am I doing? 25 cents, 24.25, and multiply that times the number of high units times 4,400. So if you take that equation right there, you should get your total level of fixed costs. And I'll do the equation, I'll do it over here. So I'm going to take, actually, let's make sure we get this fixed here. This is 120,700 is my total points, 24. That looks good so far. Okay, so if I take 120,700 and subtract out my variable cost per unit, which is that amount right there, times 4,400, I should get, and this is correct, this is your total fixed cost. So that gives you your total fixed cost right there. So we've got the two variables that will make up our line. And you'll notice that I'll do the demonstration of the line at the end, but we've got our two major variables. You've got variable cost per unit of $24.25, and $14,000 is your cost for total fixed cost. And now, just to show you, just to emphasize this, you should be able to use the low point to get this too, and you're going to use the same equation. Get total costs minus your variable cost per unit times X. By the way, I should not be using X. I should be using the units in there. So I'm going to change this to units. Usually you use X for units, but I'm not doing that this time. So I'm going to use that as units. And units. Okay. And for the low point, this should give me, this is going to give me the low point was $43,100 in costs and 1,200 units. So this is going to be 43,100 is going to be your costs minus same thing, 24.25 minus $24.25. But in this case, I'm looking to take it times 1,200 units. Okay, so I'm going to go ahead and do the equation over here. If you take total low fixed costs and then take that times minus the product of the number of low units produced times your variable cost per unit, that's 14,000 also. So you can get your total fixed costs anyway. So a couple more things. The final answer, and this is going to be the true for all of it, is the final answer that we have is we're looking for an equation which you can use to estimate your costs. We're looking for an equation which you can use to estimate your future costs at different levels of production. Okay, so here's the final answer that you would give me. if I asked you on a test, you would say, using the high-low method with these data, you would give me the following answer. Your total cost is equal to your total fixed cost plus the variable cost per unit times the units produced. Okay, and in this case, what you're going to say is that your total cost, and this is your final answer here. In this case, what you're going to say is that your total cost using the high-low method and these data is equal to your total fixed costs, which is $14,000 plus your variable cost per unit, which is $24.25, $24.25 times your units produced. And I'm going to give you, this would be your answer. That would be the estimate of cost function right there. Trying to make this bold, it's not cooperating here. This would be your final answer right there. That would be your final answer. So if I said use the high-low method to get your cost function, that would be, you could say 14,000 plus 24 times 25. Now you may be asking, why do we do this? And I'm going to go ahead and do this. I didn't do this in the original exercise, but I do it anyway. You do it to you do this in order to predict future costs. So I'm going to go ahead and copy the original data down here. Okay, and I'm just going to go ahead and put insert a couple of rows there. And I'm going to say that these are your predicted costs. And what we're going to do is I'm going to just show you what you do with these equations. And what you're going to do with the equation is you're going to use the equation to predict costs for the future. Okay, and the easiest way to do this is, what I'm going to do is I'm going to go ahead and I'm going to say this is I'm going to put in here the predicted cost using the equation that you calculated here, using the equation total costs is equal to $14,000 plus $24.25 times units. And the only thing you have to do to predict costs is to take the cost function that you came up with, which was your ultimate answer, and just plug in the number of units. Because once you get the number of units, what it's going to happen is the other two variables you already know. Okay, so let's go ahead and do this. Okay, so using this cost function, total cost is 14,000 using any either high or low point, and then we're going to take that times the variable cost per unit. Okay, the variable cost per unit is $24.25, and we're going to actually multiply that times the units that we originally observed for whatever period of time, which is that amount right there. Okay, so for the first period, we actually observed 87 for 3,000 units. We observed 3,000 units had cost of 87,200. Your prediction using this line would be 86,750 would be your prediction. Okay, and I'm going to go ahead and fix this line so that so we freeze the variables on top and can then use it to predict the others. Okay, so your predicted cost, your actual cost for 3,000 was 87,200. Your predicted cost was 86,750. Let's see for the other levels here. Okay, so this one looks perfect. Something is off here. I'm getting the exact same cost. Well, we'll fix this next time. I'm going to stop this video here, and we'll fix this next time. It looks like it worked for this one, and not for this one. I'll stop this video now, and we'll start with this one again. Actually, I stretched this out to anything beyond I wanted to do. So anyway, I'll stop this video now, and in video 2, we'll fix this one, and we'll actually go into the scatter graph and regression functions. Okay, so anyway, so I messed up a little bit. We'll fix it in the next video. These videos are short, and we'll finish with that. Okay. Thank you very much.